All right. So I have my airplane. It's very, very basic functionality, but it's another type of game object that does something besides bouncing. Cool. So I have a very basic game architecture. Everything stems from game object. But notice there's actually a hell of a lot more I can do here. So this is really annoying, right? I got balls and I got plane, and maybe I'm going to add enemies, and everything's just going to be all over the place. And one of the things that C++ can do that some people might not utilize properly is really keep everything organized. The whole point here is that when the game starts getting insane and the architecture starts getting out of hand, you want to bring everything together and organize everything, and that's what polymorphism does for you. So you probably noticed, or maybe you didn't, that the game object base class, this thing, get on out of there, the game object class has a draw and an update method of its own. Now that's probably going to be a little bit confusing because I already have update and draw methods in my child classes, and I'm not really using anything in the base class, and it really doesn't understand what this means. And that gets into the whole concept of overriding. In other words, because my draw method of plane and bouncy ball are defined here, draw and update are defined here, but they're also defined in game object, you can kind of think of it as if I'm trying to override what those functions do. In other words, I'm saying that game object has them, but they don't really do anything inside a game object. And I'm defining what they do in the actual subclasses. So here's where the concept of polymorphism comes into play. Essentially what we're doing is we're making the decision that we want game object to be an abstraction, an abstract class that can represent any kind of game object. And we want to pick specific methods of game object to become virtual methods. And all that word really means is that those methods can be overridden by a child class of game object, such that if you actually were to have an instance or a pointer to a game object and call any of its virtual methods, those methods are not actually a game object method. Their implementation lives in one of the child classes. So calling draw on a game object that points to a bouncy ball, or calling draw on a game object, or update on a game object that points to a plane, will go to the appropriate methods for each of those base classes, or subclasses. That's essentially, in a nutshell, what polymorphism does. It allows you to make the decision which method to call at runtime based off of what the game object is actually pointing to. So by defining these things as virtual, I've basically taken game object from the realm of being a regular class to a virtual class or a polymorphic class, which means that these functions can be overridden. Virtual basically means nothing more than saying that this is a special function that can be overridden by a subclass. And going a further step by using the worst syntax in the world, but this is how you do it, by setting these to 0 like so, I'm saying that, you know what, game object doesn't even know, it doesn't even have a draw and an update at all. I'm going to define what these are, and you know what, they don't exist for game object. That takes game object and makes it pure virtual. In other words, a purely abstract class that cannot be directly declared. I'll show you what I mean by that. Nothing I've done so far has broken the program run. But if I was to go into my original main file, which is called ball, and try to declare one of these game objects somewhere, you'll notice that all of a sudden I can't do it. Game object is an abstract class. Basically it's saying, hey, you set some of your functions equal to 0, I don't know what those are, you can't use it. However, watch what happens when I set this equal to being a pointer. And watch what happens if I set this being a pointer. Watch what happens if I set this being a pointer equal to the address of one of those other objects. It still works. In other words, by making this class, this base class, something that has virtual functions in it, I'm basically saying that, you know what, I want to use this as an abstraction for every game object in my entire game. I never told you guys this wasn't going to be insanely confusing, but if you spend enough time trying to figure this out, this is what makes C++ the language of choice for doing performant architectural stuff for games and everything else. And I'm basically going to explain to you guys, by just implementing what I'm talking about, how powerful this can be. So one of the downsides, if there is any, of polymorphism is that once you start using polymorphic classes and virtual functions, everything has to be a pointer because everything has to be basically done indirectly. So there is no more declaring these things as not pointers anymore. But what it allows me to do is basically define everything as a game object, and I never have to directly use bouncy ball and plane when I'm declaring my objects. So I don't have to separate these out anymore. In other words, I have one array of all my game object pointers, and I'm just going to right now just say 100 max. Maximum 100 of these things. And I'm basically going to start them all out as being null pointer. Alright. So what have I really done here? Basically what I've done is I've allowed myself to use everything in terms of game objects. So you'll see every time that I'm using balls to render them and to draw, this can all be combined now into one big array. In other words, for I equals 0, I less than equal to max objects, I++, assuming the thing is not null, draw it. Remember, these things are pointers to game objects, so there's really no way to know. It's almost like magic that it knows what object to actually, which draw function to end up in, and it has to do with whether I set the game object pointer equal to a plane or a bouncy ball or any other kind of game object subclass. It just magically knows that, hey, you know what, this is some kind of it, it'll work. I know it does have a draw, call it. And I do the same thing with update. See how I have all this ugliness combined into one thing? Well, I don't have to do that anymore. Now I can just iterate through the same loop of any kind of possible game object in my entire game and call update on it. Notice I'm using arrow notation here, meaning that these things are pointers, of course. I will say that polymorphism, as far as virtual functions, works with reference parameters as well, you know, the ampersands, but it's commonly not done, at least not when you're doing things like this. So that works pretty well. That works well too. So how do I define these things, and how do I define how they're going to work? Well, at the very least, everything inside the game objects array now needs to be dynamically allocated, which is fine. So essentially what I'm going to do here is I'm going to define these things using new and delete, which I'm going to cover in more detail in a later video. But essentially they're a fancier way of constructing objects in the way that you can determine, for starters, when they are created and when they're destroyed. And this is how you basically create pointers to specific class objects. So when I'm creating the balls here, essentially what I'm going to do is I'm going to add them to my game objects class directly. So what I'm going to do is I'm going to have bouncy ball pointer ball equals new bouncy ball. I'm going to define everything I want to do for every individual ball via its pointer. So this is essentially the ball setup for creating a game object. And at the very least, I'm basically going to say game objects there we go. Now essentially here I want to make note of how many game objects I have. So it wouldn't be a bad idea to have an integer up here that basically says num game objects. Start that out as 0. And use that as a variable that basically tells me that I'm filling up the game objects array with some global variable that will increment every time I add something to them. And there's more fancy and advanced mechanisms for doing this, but I want to cover it in a simple way before I go into more advanced data structures, which also is coming in another video. So I've created a new bouncy ball, and I've placed it inside my game objects array. Remember, game objects are pointers to game objects, and ball is a pointer to bouncy ball, and it'll just work. I'm basically placing a type of game object into my game objects array, and it'll just work later. I do the same thing with plane. Plane, plane, new plane, arrow, arrow, place the plane into my game objects array, making sure I don't screw this up. I don't want to. Commonly, what people will do is they'll put the plus plus right in here, and what it'll do is it'll increment it after it reads. It's a postfix. I just didn't want to do that up here because I wanted to show you guys simple first, and then maybe complicated later. So I've added the plane. And at a very least, because I've called new, which is dynamic memory, to create all these things, nice. When the program quits, now I just make sure that I free these things properly, which is very simple. I just iterate through my game objects array. If there is one, I delete it. And for good measure, even though I'm not going to use it anymore, it's just considered good practice, I set the thing equal to null to tell me that it's gone. Now, maybe there's a chance this will just build and work. No, it won't. Okay. It's got problems. For starters, it looks like ball. There is no set texture for ball. Oh, calling this ball was pretty stupid because I have a texture up there called ball. I really should call this ball text. That'll fix that problem pretty quickly. It says that, warning, delete called on an object that is abstract but has a non-virtual destructor. So once you create objects that are abstract, there are a couple things you have to do to get it to work. For starters, every time you override a function, that function must be virtual as well. So virtual functions, when they are declared in base classes, must also be declared if they're overridden in a child class. So I have to do that for everything that is inside my subclasses. So I've done that for bouncy ball. You only have to do it in the header file. When you define it, it's already knows it, so you don't have to do it there as well. So let me just go ahead and find my bouncy ball header file here. There we go. So these have to be defined virtual as well. And there's also an unwritten rule of C++ that every class that has any virtual functions at all must also have a virtual destructor. And this is just kind of considered something you have to do in C++. And I don't have any code in my destructors, so I'm just going to basically define these things inline to do nothing, just for the sake of this video already being crazy long. So let's go ahead and add my virtual destructors. Most modern compilers, if they're not jerks, will warn you about that, because essentially if you don't put these virtual destructors in here, you will leak memory when you delete these things, which is bad. All right, I think I've covered everything. It's got a problem here with null PR. Hold on, I just mistyped that. And as you see, everything works exactly the same. I know this is confusing to somebody who's never seen it before, but the thing to take away from this is that these are pointers of type GameObject, but it knows it will actually call a different update function depending on what these things point to. That is crazy powerful. That's the first time you've been able to ever do anything dynamic in a programming language. C++ was the first language, besides maybe like Objective-C, to really have this level of dynamic runtime type information, which is basically how this works. So I'm going to provide this code so you guys can read through it. There's no way a YouTube video is going to explain this, or you're going to be able to absorb it in just one instance of these of experiencing it in a video. But I really wanted to take my time when I did this and at least show you guys an example of how all this works. Essentially, if you were to take nothing away from this except this, it's that at the highest level, I just basically have an array of game objects now, which is awesome. Every time I add a game object to my quote-unquote game architecture or game engine, I have I can just put it in this array. I don't have to do anything unique or specific anymore to the individual types. I basically create them any way I want to by creating a pointer to them, and then I add that pointer to a more generic array of game objects, and assuming they all have update, and they all have draw, you know, it just works. And that's insanely awesome. So this is probably the worst video in the entire series as far as complexity, but it's also one of the coolest. So I really thank you guys for watching, and I hope I was able to explain this in a way that you guys can get something out of it. So, all right, see you next time.